Okay, prime factorization, greatest common factor. Here we go. List the positive factors of each function. I say start at 1, right? 1 times 15. 2 doesn't go in there, and then 3 times 5. That's it. Start at 1. 1 and 35. 2, no. 3, no. 4, no. 5 and 7. And that's it. 7. 1 times 7. And that's it. Whew. What's that called when only 1 and that number go into it? Prime, that's right. What is the only even prime number? Yeah, 2. Okay. 20. Well, 1 and 20. We've got 2 and 10. And we've got 4 and 5. 100, oh boy. 1 and 100, 2 and 50. Come on, sing it with me. 4 and 25. We've got 5 and 20, 6, no, 7, no, 8, no, 9, no, 10 times 10. You know the song, guys. Don't pretend like you're not singing along. 121, 1 and 121, and 11 and 11. So 1, 11, and 121 are the factors of 121. So prime numbers, again, just like number 3 here, are when only 1 and itself go into it. Everything else that has other factors besides itself and 1 is called a composite number. It's composed of other numbers. State whether each number is prime or composite. Explain. 23 is prime because its only factors are 1 and 23. 129, that's composite. Because I can tell that 3 is a factor because the digits add up to 12. As soon as you find a factor that isn't 1 or itself, you know it's composite. So this next part says which numbers from 10 to 20 are prime, which ones are composite. So let's just have a column for our prime numbers and our composite numbers, and we'll just put them in the right spot. So 10 to 20, okay? 10 is composite. Every even number is composite, right? Because 2 goes into all of them, except for 2, sorry. 2 is prime. 11 is prime. 12, composite. 13, prime. 14, composite. 15 is also composite because 3 times 5 is 15. 16 is composite because it's even. 17 is prime. 18, composite. 19 is prime. And 20 is composite. Great. So I have 8 problems under here for you to just quickly tell if they are prime or composite. Try them out. Prime factorization is when you break it down to only prime numbers. So get excited. We're going to write the prime factorization for 825. We're going to use a factor tree. So we just write 825, and we're going to break it down with any factors. So we need to find any number that goes into 825. Thank goodness we did those divisibility rules back in the day. I know that 5 goes in there. So let's see. 825 divided by 5, 165. So I'm going to break it up into 5 and 165. Now here's something I personally do to make sure that I keep track of all my prime numbers at the end. Once I get a prime number, I circle it just so I know that branch is done. So now we're working on 165. Now 165 ends in a 5, so I know that 5 goes in there. Let's see, 165 divided by 5 is 33. 5 is prime, so I'm done with that branch. We're working on 33. The only numbers that go into 33 besides 1 and 33 are 3 and 11. 3 is prime, 11 is prime. So here's how we write it in prime factorization. We write the smallest number first. Our smallest number is 3. 3 times. Our next smallest number would be 5. 5 times, we have another 5 times 11. Now this is not how we write our final answer. Because we have a repeat of the 5, we're going to write 5 times 5 as 5 squared. So we'll say 3 times 5 to the second power times 11. That is proper prime factorization. Break it down to just prime numbers that go into the number we're looking at here. So we're going to do a couple of these together. We might do all of them, who knows. 72. Now you find any number that goes into 72. It doesn't even need to be prime right away. So you could pick 2 and 36, and that works. Otherwise, pick 8 and 9. It'll still work out to the same thing no matter what. Neither one of these are prime, so we can keep going. 8 is 4 times 2. Now 2 is prime, so that branch is done. But 4 isn't, so 4 is 2 times 2. And those are all prime, so we're done with this part of the tree. 9 is still 3 times 3. 3 is prime. So here we go. We've got 2 to the 1, 2, third power times 3 to the 1, 2, 3 to the second power. That's how you write it. Now think of what that means. 2 to the third power, 2 times 2 times 2 is 8. 3 to the second power is 9. 8 times 9 is 72. So it should work out to the original number that you started with. 121, only factors besides 1 and 121 are 11 and 11. 11 is prime, so we just write this as 11 squared. That wasn't too bad. 225. Oh, I know 5 goes in there. Let's see, 225 divided by 5 equals 45. 5 is prime, so we'll leave that alone. Now we're working on 45. I know 45 is 9 times 5. Hey, 5 is prime. Great. So then 9. 9 is 3 times 3, and 3 is prime. So we have 3 to the second times 5 to the second. So there's 2 5s there as well. 3 squared is 9. 5 squared is 25. 9 times 25 comes out to 220. It works. 236. I don't know any factors right away, but I see that it's even. So I know that 2 goes in there. Half of 200 is 100. Half of 36 is 18. 2 is prime. All right. 118 is even, so I know 2 goes in there. Half of 100 would be 50. Half of 18 would be 9. So it's 2 times 59. 2 is prime. 59. Are there any factors of 59? No. 59 is a prime number. So we have 2 to the second times 59 to the first, which is just 59. So again, we have some problems here for you to try out. You can try out all 8 of these. Get some practice with that prime factorization. The greatest common factor is the other important thing we have today. Greatest common factor is the largest thing that they both have in common. So one way you can figure that out is with prime factorization. And I'll show you how that works here. So 40, if we broke down 40, we could say that's 2 times 20. And then 20 is 2 times 10. And then 10 is 2 times 5. So we have 2 to the third power times 5 to the first power. This would be the prime factorization for 40. 60, let's say we made 60 6 and 10. And then 6 is 2 times 3. 2 and 3 are prime. 10 is 2 and 5. So if we wrote this in prime factorization, it'd be 2 to the second power times 3 to the first times 5 to the first. So if you're going to use prime factorization, then you look at what they have in common. They both have the base of 2, and they both have at least 2 to the second power. So they have that in common. What else do they both have? They both have a times 5. So we can bring over a times 5. Now 2 squared is 4. 4 times 5 is 20. So 20 would be the largest thing that 40 and 60 have in common. Okay, that works. That seems like a lot of work to figure out what they have in common. Here's another way you can do it. Can you think of anything that they have in common? 40 and 60. They both end in 0, so that means 10 goes into both of them. So here's the way I prefer to find the common factor of these. 40 is 10 times 4. 60 is 10 times 6. They have the 10 in common, so we can bring it down here. 10 times. Then we look at what's left. 4 and 6, do they have anything in common? Yeah, they're both even. So 4 is 2 times 2, and 6 is 2 times 3. They have a 2 in common, so bring it down. Then you look at what's left. 2 and 3, do they have anything in common except for 1? No. So this is it. 10 times 2 equals 20, which is the same thing we got with all those branches too. So if you can find a larger number right away that goes into them, even if it's not prime, you're saving yourself some steps. 6a to the third b, and 4a to the second b. Okay, here's how I prefer to think of these in my brain. I like to stretch them out a little bit. 6a to the third b is 6 times a times a times a times b. 4a squared b is 4 times a times a times b. Let's look at just the numbers first. 6 and 4. Now these are pretty basic numbers. You could do what we just did over there, but you could probably do this in your head. What goes into 6 and 4? 2. Great. Do they both have a's? Yes, they do. They both have at least a to the second power. They both have at least 2 a's. So we'll say 2a squared. Do they both have b's? Yes, they do. They both have b to the first power. So their greatest common factor would be 2a squared b. So after you do a few of them, you'll see a pattern. First, you got to be able to find the common factor with 6 and 4. You just have to. But then when you're doing variables, look at the exponents, and you have to go with the smallest exponent. So this one has a to the third, this one has a to the second. So you can only go with a to the second. So let's make up a ridiculous one. This will be truly, truly ridiculous. And this will be our last example. Let's say 150 x to the 100th, y to the 41st, and z to the 90th. And we're seeing what that has in common with 200 q to the 4th, x to the 20th, y to the 40th. All right, let's just look at the numbers in front initially. 150 and 200. So I see they both end in a 0, so I know that 10 is a factor of both. So 150 would be 10 times 15, 200 would be 10 times 20. They have a 10 in common, so we'll bring down the 10. Look at the other numbers here, 15 and 20. Do they have anything in common? Yeah, 5 goes into both. So 15 is 5 and 3, 20 is 5 and 4. They have a 5 in common, so bring it down. Look at what's left. 3 and 4. Do they have anything in common? No, not except for 1. So all we're left with is 10 times 5, which is 50. So 50 is the largest thing that goes into 150 and 200. There we go. We've handled the difficult part. Now the easy part, the variables. Q. I see a Q over here, which comes first in the alphabet around all these letters. Do they both have Q's? No. So we can't take out a Q. Do they both have X's? They do. This one has 100 of them. This one has 20. We have to go with the lowest amount. So they both have at least x to the 20th power. Do they both have y's? Yes. This one has 41 of them. This one only has 40. So they have at least 40. Do they both have z's? So we can't have a greatest common factor with a z included. So this would be our final greatest common factor. That was tough. That was ridiculous.